This puzzle is called Polaris by Stout. I got it from the Sudoku Testing Submissions channel on the CTC Community Discord. Let's take a look at the rules. So thermometers, the digits along thermometers must increase as you get away from the bulb. The bulb is the circle, so um, let's say this was a 4. This would have to be bigger than a 4, so let's say 6, and then this could be bigger still, so let's say 7 and then 8. Yeah, it's pretty simple, and obviously, since digits get bigger as you move away, digits get smaller as you get closer. So if we found out that this was the 4, this would have to be a 1, 2, or 3, and again, this would have to be bigger than the 4. Numbers in cages cannot repeat. I don't know if that matters, but the digits in the cages sum up to the number given. So these two numbers are going to add up to 8. These three numbers, are going to add up to 17. Let's see what number clues outside the grid indicate the sum of the cells between 1 and 9 in that row or column. So that's called sandwich clue. So somewhere in this row, we're going to find a 1. Let's do this one. In this column, somewhere we're going to find that there's a 1, and somewhere else we're going to find that there's a 9. Okay, obviously that's not going to work, whatever. The cells in the middle that I just highlighted green are going to sum to 13. Same thing for the 2. So somewhere we're going to find that there's a 1, and somewhere there's going to be a 9. In the middle, there must be a 2. And also the same for the 35 and the 32, although those will be much bigger gaps, I guess I should say. Okay. Cells with V in between must sum to 5, so these two digits are going to sum to 5. If this was a 2, this has to be a 3, for example. X's must sum to 10, same as V's, except obviously 10. So if this was a 3, this has to be a 7. And then one thing that's not listed on here are the black dots. Those are called ratio dots or black crop key dots. So how do I want to explain this? There's a ratio of 1 to 2 between the two cells or between the two digits. AKA one of the two numbers is double the other number. So if we found out that this was a 3, we need to, in order to, let's do it right here. If this was a 3, this black dot means that this cell is doubled or half of the 3, so we can't do 1.5 obviously, so this would be a 6. If this was a 4 though, this could be 2 or it could be 8. Both would be acceptable answers there. I'm not sure how hard this is, but yeah, let's give it a go. So the first thing I see, probably because I like sandwich clues the most, is 35 is the maximum amount for a sandwich. So in a full column, let's do it this way, yeah, in a full column, we're going to have the digits 1 to 9 all exactly once. If you add up the digits 1 to 9, you get 45. 1 plus 2 plus 3 plus 4 plus 5, all the way to 9 is 45. Now, in order to get 35 for a sandwich clue, we have to take off the 1 and 9, so we don't count the 1s and 9s, and which sum to 10, and then we need a bunch of stuff adding up to 45, or sorry, to 35. So if you take 45 for the full column, take off 1 and 9, you get 35 left over, which is the amount that we need for the sandwich, so we put the 1s and 9s as far apart as we possibly can. Okay, so now the next thing I see is this, these black crop key dots, the ratio dots. You can never put a 9 on a ratio dot because, of course, doubling that would be 18, which is way too big. And having it would be 4.5, which also isn't a valid entry into the Sudoku. So this must be the 1, and this must be the 9 up here. Now we need to double 1. Now we need to halve or double 2. So theoretically it's 1 or 4, but we just used the 1, so it can't be 1 again. So this is a 4. Now we need to halve or double 4 in both of these, but this 2 sees both of those, so both of these must be 8. Okay. So now this killer cage, theoretically there are 3 different pairs that add up to 8, but we've already used the 1 and a 2 in the column, so this must be 3, 5. 5 cannot be on a crop key dot, or a black crop key dot, because If you try to double it, we're above 9. If we try to halve it, we get a a decimal or a fraction or whatever you want to say. So it must be 3. And again, we can't have 3, so we must double it. So both of these are going to be 6, and then remaining in the column is 7. We need to increase from 7 on the thermometer, but we've already used an 8, so it must be a 9. Okay, let's just fill out this V. Now this can't be a 1 because we've already used a 1. So this can't be a 4 because this 4 would require a 1 here. This can't be a 2 because of the 2 there, so this can't be a 3 because 3 requires 2, which we just rolled out. So if this is a 2, this could theoretically be 1 or 4, but we've already used the 1, so it must be a 4. If this is a 4, this could be a 2 or an 8. So this could be a 2, 6, or an 8 to match up across the X. Okay. I don't actually know if we can do anything more right over here, at least immediately. Let's look at these cells. Let me think. So I'm just trying to visualize a little bit. I don't know. I don't see something there. Let's look at the 32 column, I think. So 32 is going to be all but the number 3. The number 3 is going to be just outside the grid, so we don't know if it's on the top or the bottom. But one of these pink cells is going to be outside, and then we'll have 1s and 9s like this. So how can I... So there's basically 2 options. It's either 1, 9, 3 like this. This is one of the options. Or it's going to be 1, 9, 3 like this. So we actually can reduce a couple. So this is a 1 or a 3 since it can't be a 9, and this is a 3 or a 9. Maybe it is this box right here. Let me just type this out. So 1, 2, 3, 4, 5. This can't be a 1, and this can't be a 5 for the thermometer. This can't be a 5 because of the Kropke dot. This can't be a 3 because of the black dot either, because we can't go to... I guess neither of these can be 3s because 3 has to go with 6, like over here. Now 2 needs to be within the sandwich. So I guess if this was 1, like this could be a 2. Like the bulb could be 2 if we did 1, 2, 9 right here, but this can't be a 2. That is for sure. Does that actually help at all? This is 1, this is... So this is 1, 2, 4, or 8. Okay, maybe I'm just missing something that's more obvious that I'm just not realizing. 13 I don't think will be helpful. I was thinking when I was talking about this on the right that 1 would be... Maybe 1 is ruled out because we can't use the 9. Yeah, that's what it is. I was thinking this was a bigger cage, so we would never be allowed to have 1. Then I saw it was a 17, which can have a 1 in it. But actually there's a 9 looking in, so we can't have a 1 in it also. Okay, so let me just explain what I mean here. So if this was a 1, this 17 cage, we would need these 2 digits to add up to 16 then, which is normally possible, except we've already used the 9, so the biggest 2 digits we have are 7 and 8, which only add to 15. So if we put a 1 here, the biggest we could make this is 16 instead of 17. So this can't be a 1, which means it must be a 3, which means this must be a 1, 9, like in this situation. Sorry, my throat is really scratchy this morning for some reason. This adds up to 14 because we already have a 3. There are 2 ways of making 14, but we've already used the 9, so it must be 6, 8. Yeah, I don't think filling this in was helpful at all. I'm just like looking over there at that mess and like, yeah, that's not helpful. Right here, let's see the options. Normally the options on a Kropke dot, or a black Kropke dot, are like this: 1 and 2, 2 and 4, 4, 8, and then also 3 and 6. But we've already used 3 and 6, and we've already used the 8. So there's that. It's actually pretty restricted. So only 1, 2, and 2, 4 are left, which means we're going to have a 2 in one of those cells, no matter what. This could be... I was seeing if maybe the 2 is lined up down here, but this could be 4, 8, and and not use a 2 at all. Okay. So we need a 5 in in row 1. This must be the 5 because this 5 rules out 5 along here. So this is 1, 4, and 7. And one of those two must be a 7. We're going to take the 1 and the 4 that we don't use here, or the 1 or 4 that we don't use here is going to go over here with the 7, yeah. 8 must go in one of these two cells. Don't know if that's helpful. I feel a sneeze coming on, so if I randomly mute, that is going to be why. Maybe not. Okay. 6 is in this here, but I don't know if that's helpful. 4, 6, 7, 8. Yeah, that's not even if we made this the 4, it's not restricted enough. We still have a couple degrees of freedom, so that's not quite helpful. Which clue? We've done we've done these 2 clues. We've not done this clue, but I don't think we don't have much to go on except that this is not a 1 or a 9. Which doesn't, I mean, that's the most basic of information for sandwich clues, just that this is not 1 or 9. We've already done both killer clues. Oh, I guess we have a 9 in one of these 2 cells. Yeah, I don't know if that's helpful. 13 could be made in a number of ways, so I don't know if that's helpful either. Maybe it's this. I don't know, we did just work up here, and it seemed like these clues lead from one to the next pretty smoothly. But I do not see what to do up here with the information I just typed in. A 5 along here? No. I guess 3 and 6 are both in this, and this cannot be a 3, because that's way too far along a thermometer. If this was 6, that would be fine. This could be a 6 just fine, I think. And have 7, 8, and 9 be kind of outside the thermometer, or off the thermometer. Yeah, I'm not sure. Okay, so let's look down here. So if this is... If this is 2, this is always 4, so this would always be 6. But if this is 4, this could go up or down, but we use both 2 and 8 in the row. If that first digit is a 4, does that matter at all? We have used... Actually, we've used 3 low digits in the column. And we're going to use another low digit in here. You need 1 low digit to make a 10 pair. You take like 1, 2, 3, 4. You add that to 6, 7, 8, or 9. That makes the 10. Of course, you have to add them up, with the partner, but it's always going to be 1 low digit, 1 high digit, is what I mean. So so this can't be a 3. Yeah, we've used up 2 low digits here. We're going to use up 1 in this pair, and we've used up 1 here. So this can't be a 3. If we did this as a 3, we can just easily go through that. Okay, now how do we make a 10 pair? We can't use 1, 2, 3, or 4, and we can't do double 5. So the minimum we could type in here is 5 and 6, which is obviously bigger than 10. So this can't be 3, so this is 3, which means this can't be 4. Does that help? I don't know. Well, could this be a small digit? The biggest small... could this be... Oh, this can't even be a 4 because of that 4. So this... I think this must be the small digit up here. But, like, if this was a 1, 2, or 3, then, yeah, none of these are going to work with the thermometer. So this is going to be a 1, 2, 3, or 4. This is going to be a 6, 7, 8, or 9. Can't be a 9 because there's no digit bigger than that. Can't be an 8 because of the 8 right here. Sorry about that. Yeah, maybe I'm keeping this cold around for longer than I thought. I thought I saw something, but I could have ruled out 4 again, but that doesn't help. I don't need multiple ways to rule out 4. Yeah, I guess these two are going to add up to 5, however helpful that is, because these two are adding up to 5, and this has to be the other pair. Yeah, that's not super incredible. So this is 6 or 7, so this is 7, 8, or 9. Not quite ruled out yet. 8 must be in one of these 3 cells. I don't think that matters. If this is 8, this is 4, this is 2. Which means this is an 8, and this is a 4, and this is a 1. I don't think that matters. This is a 3, then. Yeah, I don't think any of that matters. If this is a 4, this is a 5. And then this is 1, 2, 3. Again, I'm not seeing the thing there. I was cruising there for a while at the beginning, and I'm just feel like I'm missing something obvious. I've been kind of slow this morning. I did 2 other puzzles before this, and I just did not handle them very well. I was very slow. At least with the first one, it was just like laughably slow. Let's see if I can spot what I'm missing here, though. Oh, okay, so we need a 5 in this box. Obviously we've already ruled out 5 from a number of the cells. We have a 5 up here that's ruling out there, so we have a 5 looking up. So one of those is a 5. If this is this must be at least a 3 because it has to be greater than minimum of 2. But actually, if this is a 2, this is a 3, so this can't never be 3. So this is at least 4, 5. This is 4, 5, or 6. I didn't think about that. Could this ever be 4? This can't ever be 4 either. If this is a 4, then obviously this can't be a 4. If this is a 2, then this is a 4, and this can't be a 4. One of these is a 4, which I guess I didn't think about precisely. I don't know how helpful it would have been up until now, but it's always nice to just notice those little tricks. I guess one of these is a 3, because of this 3 that's looking down. What can this digit be, actually? So this can't be a 1, 2, 3, or 4. Well, I mean, it couldn't be a 1, 2, 3 anyway, but couldn't be a 4 because of the 1, 2, 3, 4 quadruple we have in this column. It can't be a 5, it can't be a 6, so this is a 7, 8, or 9. Now, it can't be a 9, because that would mean this is a 7 or an 8. Sorry, no. This can't be a 9, because that would mean this digit would have to be greater than 9. And you can't do that in a Sudoku, so this is not 9. So this is 8 or 9, which means it's not 6, which puts a 6. Okay, that's what I'm missing. There we go. Off to the races once again, or at least short sprint. That makes that a 3. That makes that a 5. That's a 2. Ooh, 1, 4. No, this is an 8. This is a 9. No, we still are not quite getting 5 or 9. Not quite getting everything resolved. Oh, darn. This puzzle's definitely trickier than the beginning kind of let on. Well, I mean, obviously you could see I kind of breezed through the first, I don't know, 3, 4 minutes of the puzzle, getting a lot of progress, and then a lot of trickier stuff, which is nice. I like trickier stuff. So we have a 1, 2, 4 triple here, which means this can't be a 1, 2, or a 4, and also this can't be a 1 or a 4. So that's the 7. No, we can't. I don't think we can do anything else with that triple. At least, not that I see immediately. 1, 2, and 4 were already ruled out of these 3 cells, so I didn't need to mark it down in any way. Well, this couldn't have been a 2 for the longest time. This could never have been a 2. If this is a 2, this is a 1, and then how do we fill this digit? We need something that's double 1, but not a 2. That obviously doesn't exist. So this can't be a 2, which means one of these two digits is a 2, no matter what. Which means this can't be a 2, which means this is a 2. Yeah, I think that's fine. This 3 means this is a 5. Which means this can't be a 4 any longer. We have a triple here. Whoops, not there, here. What's left in this column is 5 and a 7. We have a 5 looking over to figure that out. What's left in this box is 1, 4, and 7. That 7 does not look up and figure this out, unfortunately. These two are 4 and the 7, once again, causing problems for us. With this 2, 5, and 9. Now this is a 9. Or, sorry, not a 9, because we have a 9 down here. Oh, we have a 7, so this can't be a 7. We can fill this in 9. 3, 6. This is 3, 6, and 7. This can't be a 7. Yeah, where do we put a 7? I guess we could have done Sudoku this way. 7's looking into box 9, which actually give us a couple 7s. And this can't be a 3 because of this. So this is a 6 and a 3 like that. So this is a 2 or a 9. That's all that's left. Okay. We haven't used this 2 yet. I guess this can't be a 2 any longer now. Before we said this could be 2 if this was 1, 9, exactly like this. But we've already put 9 into column 5. Whoops, so this can't be a 9, so this can't be a 2. Which makes that a 2, makes that a 1. So this is a 1 or a 4. Digits can repeat like this, the same way we did right here and right here. But they don't have to. This could be, yeah, this could be a 1 or a 4. Entirely independent of the other dots. Let's see, so we haven't, oh, so now we need, okay, now we need this 2, and we've found one of the crusts of this sandwich. So we need to put a 2 next to the 1. It needs to be 1, 2, 9. That's the only way to make a 2 sandwich, is 1, 2, 9 like that. Okay, so yeah, where does 8 go in box 5? Obviously, a number of stuff is already ruled out. And then we have this 8 here, which rules those out. So 8 is in one of these two cells, which looks down here. Excuse me. Yeah, my throat is not cooperating. This 2 is going to resolve a bit here. Oh, and this 1 actually resolves a bit more than I noticed initially. Okay. So this is a 1, 4, or 7 for the column. Yeah, that looks right. Unfortunately, we can't reduce that at all. Okay. What about here? This is 3, 4, and 6 that's left. This can't be a 3, this can't be a 4. Oh, we have this 8 here that we've had staring at us for years. Okay, this is 1, 2, 5. This can't be a 1. We do have a 2, 5 pair. Minimally helpful at the moment, I think. But maybe in a couple of minutes once we start figuring out this box 6 a little bit more. Okay, oh, we haven't done the 13 clue. That's what we need to do. Okay, so we have a 9. This can't be a 1 because we need to fit at least 13 in here. In fact, how can we fit 13? If we put, this is 4, this is 1, and that's only 6. So this can't be the 1. If this is a 1, yeah, this is just going to be 6. So this must be the 1 up here. This is going to be a 4, and now we have 9 plus 3 is 13. Okay. So this is 8. We have 1 over here. We have 6 down here. Okay. So now we need to just break into this cell here, or this box here. What's the minimum for this is 3, since we have a 1 and a 2. Let's just do minimums up the line. This can't be a 4 or a 5. Actually, this just must be a 6, I think. Because it can't be... It could theoretically be 1, 2, 6, just by the options in the cell, because it sees 3, 4, 5, 7, 8, 9. But it can't be a 1 or a 2, because we can't put anything less than a 1 or a 2 into the bulb. So this is just a 6. Which is going to help us a bit. Actually, quite a bit. So that means this is 3 or 5. Just since it can't be a 4 either. So this is 7 or 8, and this is 8 or 9. And this can't be an 8, so this is a 9. So this is not a 9. Oh, and this can't be a 7. We have a 7 right there, so this is an 8. So we have a 3, 5 pair in the row. What's left here is a 2, 4, and we have that 2, 5 pair here figuring that out. So this can't be a 2 as well. This must be a 4, which makes this a 2. Rules out a couple things. This is a 7 and this is a 1. So this is 5, 2, 5, 2, 1. And what am I missing? Oh, 3 right there is 3, 5. There we go. Yeah, that was not as simple as you definitely thought. You know, starting out, it was like we breezed through the first, I don't know, 10th of the puzzle or whatever. But then didn't it definitely got a lot trickier with all the stuff going on in like column 5. That was a lot of fun. I think Stout said that this was their first puzzle. Let me see if I can find that. Oh no, sorry, second attempt. Um, but yeah, very good job for an early puzzle. This is a very good job. Um, yeah, I enjoyed that. The beginning was a lot easier than it probably needed to be. A string of black Kropke dots like this is like this, there's only two options. It's either 1, 2, 4, 8 or 8, 4, 2, 1. So you probably don't need to give away that much information right off the bat, but like that logic in the middle, I really liked that, figuring out that, hey, there must be a 1, 2, 3, 4 quadruple in here. So therefore, you know, we were limited up. I think it was up in box 2. We were limited. Um, yeah, that was very nice. Yeah, so thank you, Stout, for that puzzle. Great job for your second puzzle. And thank you all for watching.